Continuation numerical from the oscillation. See, for this, a block of mass m is attached to one end of a light inextendable spring passing over a smooth light pulley A. Another smooth light pulley B as shown in the figure. The another end of string is fixed to a ceiling. A and B are held by springs of force constant K1 and K2. Find the time period of small oscillation of the system. So we can find time period, frequency and angular velocity also. Okay, but in this question asking only time period. Okay, see, continuation here. One thing clearly we have to understand, this is get by small vertical displacement y, like this y. What is that? M block. Okay, so this displacement is y by 2 and this displacement also y by 2. So y by 2 is y only. Here also pulley 2 also get displacement y by 2. This is upward direction, this is also upward direction, this is downward direction. So here due to displacement, this pulley get displacement y by 2 downward direction. What is that? Y by 2 downward direction. This is y by 2 downward direction. This pulley is y by 2 upward direction. See, okay, so this pulley approximately, so like this, y by 2 up. Think practically here. Pulley A downward direction y by 2 due to the force constant K1, which is spring. This is connecting to the rigid support. Here also another rigid support and second pulley, that is force constant of the spring is K2, which is connecting to the rigid support. So force developed in the spring we have to find for the K1 and also K2. Both are fixed to the rigid support and connected to the pulleys. Okay, so for this, force in springs. So tell me now, for force developed in the springs, think practically. So this is the tension. So upward direction, how much tension is acting here? 2T is acting. T plus T is 2T. Here also tension is T. Here downward directions, T tensions acting. Here also tension is 2T acting towards the rigid support. So there is a change in the spring constant due to the elongation from equilibrium position to the oscillation from the main position of the system. And continuation, now the force developed in the spring is 2T, which is equal to 2T, which is equal to, okay, so F is equal to Kx formula. So F is equal to T and the Kx value is here K1, X value is y by 2. From this equation here, T which is equal to K divided by 4, K1 divided by 4 into y. Here K1 dash which is equal to K1 divided by 4 we are considering. Okay, so for second one also we will get 2T which is equal to K2 y by 2 only. See, directions are opposite but magnitude is same only for the both pulleys and springs. So T which is equal to K2 divided by 4 into y here. So K2 dash which is equal to K2 divided by 4. Okay, so the resultant diagram of this system is like this. See, this is the rigid support, this is the K1 dash, and this is the K2 dash. Values we got already. So this is the block of mass M. This is the resultant diagram of the given question. Okay, so these two springs are in what combination? Here in series combination. So the series combination. Okay, what is the formula for series combination? 1 by K equivalent, which is equal to 1 by K1 dash plus 1 by K2 dash. Okay, so this is the series combination for the given question. Okay, so now continuation, that values are 1 by K equivalent, which is equal to, that is 4 divided by K1 plus 4 divided by K2. So K equivalent, which is equal to, what is the value here? Okay, so we can write K1 K2 divided by 4 into K1 plus K2. Okay, so we can write directly formula in the time period. What is the time period formula? T, which is equal to 2 pi root over, okay, M divided by K equivalent. So here K equivalent value we have to replace, no space, just we can write here time period. This value is replaced here, time period T, which is equal to 2 pi root over, okay, M divided by, so M divided by this value we can replace like this, 4M, okay, so K1 plus K2 divided by, okay, K1 into K2. And what is the frequency mu, which is equal to 1 by 2 pi root over K1 K2 divided by 4M into K1 plus K2. What is the angular velocity? Omega value, which is equal to root over, the value is K1 K2 divided by 4 into M into K1 plus K2. These are the important formulas for the given question. This is the first formula, this is the second formula, this is the third formula. But in the question asking only first one, but there is a chance to ask remaining also in the competitive exam. Okay.